recording started. I want to thank everybody for joining Astrix for today's session entitled Creating Your Digital Lab of the Future, a Blueprint for Next Generation Laboratories. Before we jump into today's session, we're going to go through just a real quick introduction of who Astrix is, a little bit about the different services we provide, and then I'll introduce our speakers, Ken and Dave, and then turn it over to their capable hands for the rest of the presentation. Ken, you can go ahead and go to the next slide. So if you haven't been on any of the Astrix webinars, we welcome you. We're glad to have you. If you've been on some of our webinars, we're certainly glad to have you back, and hopefully it means you've enjoyed the content that we put out in the market. Just in terms of who we are as a company, Astrix was established way back in 1995. We are a company that works with lots of different technologies. We are a professional services firm that works with a lot of different technologies in the life science space. We're not really aligned with any technologies. We stay neutral because we want to be able to select the best solutions for our customers based on their unique needs. We operate with locations both in the United States and overseas, staffed by over 2,000 employees. One thing that we're super proud of is that greater than 90% of those team members hold advanced science degrees, because of course we are a science-based organization ourselves, helping science-based organizations like yourselves. The type of companies that we help are everybody from startups to Fortune 1000. We help life science enterprises, chemical companies, CPG, government agencies, research institutions. Chances are, if you have a laboratory, there's services that we can provide to help you run that laboratory more efficiently. And about those services, we can go to the next slide, Ken, about those services. So there's a full spectrum that we use to accelerate digital transformation and optimize performance across your entire ecosystem. That can begin with some of the more strategic things, similar to kind of what we're talking about today, which is helping you figure out, where you're going as a laboratory. That can be everything from strategy to people to the technology, where we get into things like enterprise architecture. What is your stack going to look like from a technology standpoint? And then from there, once that's mapped out, we can help with solution selection services. From there, we can even go as far as helping you develop and implement these systems. When those systems are implemented, we can make sure that they are properly validated with regards to FDA guidance, and we can provide ongoing application support, delivered in a variety of different ways. One of those ways is we can provide staffing services, so we can actually staff your laboratory just with science-based personnel, if need be, independent of any project, or we can staff your technology team with our great staffing department here at Astrix. So that's a little bit about the company, a little bit about the services that we provide. I'd like to introduce our speakers. So two gentlemen that I've had the pleasure of doing a couple webinars with, Ken Raiche and Dave Dorsett. Ken's a managing director here at Astrix, and Dave is a principal software architect here at Astrix. I won't step on their toes and go through their backgrounds, but I will say, having been on a number of webinars with them in the past, two super smart, sharp guys who know their stuff, and I'm going to sit back and enjoy the presentation as much as you are. So Ken, I'll pass it to you, and I'll come back on at the end to help with the questions.
Yeah, sure. Thanks, Kevin. Really appreciate it. And thanks to all the attendees for joining. It's great to see a lot of familiar names in the list. So that's really wonderful. Dave and I were talking just a few minutes ago before the presentation. We need to get headshots of the future out there at one point in time here. So, but without further ado, I think we'll hop into we'll go ahead and hop right into the content. All right. Let's see here. So digital lab of the future, right? So what does it mean? And where has it been talked about in the past? So, the internet only goes back so far. But if you do a Google search, you can get back to about 2001, 2002, when people started talking about paperless labs and lab of the future. But guess what? We're already in 2023. And I'm sure before the internet, right, people were talking about lab of the future as well. Dave and I talked about this, talking about the early 90s and whatnot, when Dave was doing a lot of this as well, that same term existed. Which brings us to the point of, really, what does lab of the future mean to you? And that's really where we're getting at. From an Astrix perspective, one size doesn't fit all. There isn't necessarily the lab of the future. It's really your lab of the future, right? And a lot of the lab of the future concepts that are out there exist, with a lot of the buzzwords that we've been hearing and seeing constantly through conferences and symposia, as well as just any meeting that you have. You can't get away from a lot of the terms that are being used out there. So a little Star Wars effect here, but you get artificial intelligence, right? AI, virtual reality, low friction collaboration, machine learning, digital twins, automated reports, your ELN systems, harmonization, ontologies, cloud first, fair data, that's a big one, right? Data mesh, data lakes, paperless labs, instrument connectivity, best of breed versus platform, digital assistants, data orchestrations, low code, no code, and of course, digital transformation. These are all buzzwords that we hear, every single day. And what it boils down to is really understanding what your lab of the future should be, right? So, and this will most likely be quite different than someone else's lab of the future, your lab of the future, that is, but they all really have the goal of allowing your scientists to do more science and empower better science, right? I don't know, Dave, if you've got any thoughts on that.
Yeah, I think, one of the, at the end of the day, we're constantly being driven by, becoming more efficient, becoming more effective, right? That's been an underlying theme for decades, in this, and certainly part of the underlying, pushes for quote unquote lab of the future initiatives are exactly those two things, right? So, given finite resources, finite, scientists, finite budgets for running experiments, et cetera, how can we be better at doing that? And that has been one of the, underlying, like I said, underlying pushes for decades now. Constrained budgets, constrained resources. How do we do better with this? How do we make better use of our data? How do we, on and on. So those are the principal things we'll be talking through. What does that look like these days? Yeah.
Right. And when we've been talking about it, right, we've really been talking more about, say, lab optimization, right? And many initiatives in this area have been labeled lab of the future, regarding lab optimizations. And really what we've seen, and everybody on the list of attendees that I can see has probably experienced a huge amount of buying and developing software to digitalize the laboratory workflows for the last 20 years. So this lab of the future concept has existed. I would say companies have done a good job. Of course, if you could be Michael J. Fox and go back in time and change things, you probably would, right? But over the last 20 years, yeah, we've primarily gone paperless and got a lot of benefit out of that. But by buying a lot of software and maybe not having the technologies that exist today, we've gone through some learning experiences, right? And some of those have been unintentional data silos have been created and fortified, right? Multiple systems have been purchased for similar workflows and experiments. Oftentimes we'll see departments having the capability to buy their own software. So you have multiple LIMS systems doing the same thing, or multiple ELNs doing the same thing. And that makes a single source of truth really, really challenging to have. Integrations, I think we've all seen them. They've either, many of them have been over-engineered, several have been under-engineered. And really a thing of the past has been point-to-point data flows and point-to-point integration, which really is costly for an organization and difficult to move forward with, right? ELN and LIMS vendors, Dave and I lived through both of these. We've been employed by them in the past as well. In an attempt to merge these capabilities, they merged the two names together, ELN and LIMS. So it's made it a little bit challenging and difficult for some companies to understand: do they need an ELN? Do they need a LIMS? So this has been part of the learning experience as well. Paper on glass, quick to deliver and deploy to a huge number of people for like an ELN deployment, but really has not been able to deliver on the value for utilizing that data. Data lakes were introduced to correct the misses of warehouses, but created new problems, of course. And then there's been cross-industry standards initiatives, right, that have had some adoption challenges and have struggled to deliver scientific value. So these are all the learning experience, at least, that we were able to jot down and create through what we've seen in the last 20 years. Dave, any comments on these that you'd like to highlight?
Nothing particularly comes to mind. I mean, I think that everybody's experienced at least one of these, if not if not multiple of these. And you know, we'll talk through a little bit about sort of where things are going from here, you know, based on learnings. I mean, the one thing about this space that you know, folks who have worked with me know that I will say fairly frequently is there are no such things as absolute right answers to a lot of this, like how to actually achieve, you know, a gain in productivity, how to, you know, go about exactly implementing. There's no book you can pull down and sort of look it up. What there is a lot of it, you know, what there is good experience, right? Certainly on things not to do and things that have worked as well. And, you know, we'll talk a little bit more about that, you know, in the next couple of slides or so. But, you know, these all, it's not a finger pointing exercise. I think with hindsight, we look back at the things we've done, you know, even relatively recently, and are constantly sort of, well, that can be done better, right? There's a learning exercise, you know, in that. And I think, you know, the place we've gotten to collectively here, you know, has a lot to do with what we didn't know, right, at times, and things that are out of our control as well, boundary conditions around you know, just the way organizations grow and you know, needs have to get met sometimes without sort of a full plan for the future in mind. So, yeah.
And the technology, right, has really improved in the last five years. There are out of the box solutions out there that simply did not exist, right?
Yeah, obviously big changes from a technology perspective, just generally, you know, I mean, and the building blocks for creating, you know, systems at a high level now are very different now today than they used to be, and are constantly changing as well. And you know, it's challenging to predict what's going to happen in that space, and you know, and there's always a measure of, you know, sort of risk reward for where you want to be on the new technology curve, based on, you know, your tolerance for not quite getting it right, et cetera. So those are all things, you know, that are also contributing to all this, you know, that we will constantly have to iterate, constantly have to readjust our expectations. Yeah.
Exactly. Yeah, so let's get into some of that, right? So just continuing on the theme, lab optimization, lab of the future, you know, what's happening now. You know, most organizations, not all, and here at Astrix, we find several organizations who have not gone paperless yet, but they really have the opportunity to learn from those past 20 years what not to do, right? So it's actually could be in a very good situation. So, you know, going paperless, you know, eliminates the cutting and pasting content into an actual physical notebook. We all know that, right? It's clear that scientists are still burdened by inefficient processes for data capture and analysis. But guess what? You look at anywhere and a scientist will have Excel up because they're cutting and pasting from one application to another, doing analysis offline in Excel, or just simply cutting and pasting, or you know, where not possible, actually transcribing that digitally into different systems. So we see as part of this lab of the future is really getting rid of that as one of the goals. Other goals, you know, scientists need to become more efficient in communicating results. You know, you know, we've gone paperless, so to speak. Now it's really about results. Organizations must extend the impact of data across more geographically diverse teams. You know, we're running 24/7 these days, global, with global teams. They need the information now, right? Step changes in R&D team productivity are anticipated through deeper data analytics capabilities. So AI, ML, can't go without saying those two acronyms. And results data must become more flexible and available beyond the systems and people that created the data. You know, Dave and I talk about this one all the time. It's like you can't be handcuffed by technologies. Your data needs to outlive the systems that they were captured in.
Right. Yeah, I think that latter one's really become, I'll speak to this a little bit more as we go on. This latter one's become more and more significant. We've now been through several decades, it's been pointed out already, of implementations of a lot of these primary operational systems in the lab, particularly ELNs and LIMS. And we've had our vendors go through their changes along the way. Tremendous amount of M&A activity, of course, in the vendor space, and shifts, necessary shifts, I should say. I was speaking before about the technology changes, the underlying technology changes, the LIMS and ELN systems that were built, with what we knew to be better practice from a software engineering point of view 20 years ago, do need to be updated. Those changes and those updates are significant. So, I'm certain there are people on the call who have been through this exercise. And I think one of the critical learnings out of a lot of this, going through this a lot of our replacement exercises now, is that we really would like to be in a position where going forward we separate the data, particularly the more critical data, from the systems themselves. We really want our data to be more system independent. Now that's a great goal. That can be in its entirety. That can be obviously very challenging to actually accomplish. So we'll talk a little bit about how you might be able to accomplish aspects of that. Sort of back to an iterative sort of fashion. What you define as data, what you define as the more valuable data versus lesser valuable data, and how you might actually sort of be able to break that up. But this has become a very big, consistent theme. Is how do I at least improve my position on becoming more independent from a data perspective of the systems themselves.
Yeah, exactly. And one way to look at this, let's just take a look at a diagram real quick of a high-level systems architecture. This could be a lab of the future type of systems architecture, but really what we want to do is just highlight the areas that we'll be diving into in the next several minutes here. Really what we look at are on the top level here is really the operational systems, your ELNs, your LIMS, your LES systems, your reference systems like equipment and materials, for example. Really, these are the systems that have had a ton of focus, right, for the last 20 years or so for digitalization of the lab. We're finding a lot of our customers are now trying to swap out whatever they bought as their ELN now for something else, or LIMS, and a lot of these systems and vendors are really progressing with the times and as well. So we are seeing a shift in, like David just mentioned, around replacing some of these systems, updating these systems, questioning whether or not we need all these systems as well. But really, for the lab of the future systems, at least what we put over here on the left-hand side and shaded in green, that's really what we're talking about today. It's really the enablement layer that is new. I wouldn't say new, but has new technologies in it, new thoughts, and really allowing scientists and organizations to really grasp and harness an ROI on their data. Dave, any other comments on this before we head into some of the main industry trends?
No, I think that's important. Again, today we're not going to talk a whole lot about the upper level systems. That's another discussion, more about like how the systems play together, or some of the current views, at least, about how to put systems together in such a way to enable some of these, like I said before, these changes in efficiency and effectiveness that we're looking for out of those operational systems on the top.
Yeah, awesome. So as we were preparing for this webinar, we tried to consolidate some of the key industry trends around lab of the future into 4 main buckets that we can talk in the next several slides more in detail about. And certainly after this webinar, if you guys want to dive into these more, certainly connect with us as well. But the 4 areas that we're going to look at are workflow and data orchestration, right? Big, huge topic today. not only for orchestrating data for operational efficiencies, but also analytics, practical data governance programs, improved data management technologies, and expanding the use of data, and of course subtopics there of AI and machine learning. So yeah, I think yeah, go ahead.
Yeah, I was gonna say, hopefully as we go through this now, we're gonna go through each of these 4 areas. You'll understand like some of the rationale for why we separated out into these 4. There's each of these in and of itself could be substantial discussion and details about what does it mean, what's its impact, et cetera. So I'm going to try to do here. I'm going to try to basically sort of lay out what these things are, or what things I'm putting into these kind of categories, why they are being used today, what kind of benefits are people achieving or hoping to achieve out of these, and then some of the underlying sort of industry level trends, in and around them. These 4 are very different in category, which is why they're kind of separated in different pieces. This first one here around workflow and data orchestration platforms, this is some of the newer stuff that's becoming available, marketed in the industry now. Obviously, it's not just a sort of an immediate change. Some of this has been going on for quite a while. This goes back essentially to classic request systems, which of course have been around for any number of years, test request, result request systems. But we're seeing, more adoption of these types of workflow automation and orchestration systems at broader levels than just simply sort of like operational, requesting systems, material requests, batch request or test request kinds of things. Seeing broader use of these types of orchestration systems to direct and encapsulate the work across what might be multiple operational systems. So achieving a result, might require an ELN, set of records from an ELN perspective, or ELN related work to produce a batch of material, which then becomes then part of using a sample registry to record the things that are coming out of it, and then going forward to tests. And so you might be bridging multiple systems there with work processes that need some high level oversight, either from a planning perspective or otherwise, right? Knowing what work has to be done or what work is actually coming. That's the type of orchestration I'm referring to here. A lot of the systems that are now that are in this space are sort of, some of the ones where we see a lot of the quote unquote no code or low code approaches to things, configurability as opposed to customization. There's a gray line between what, like you take a system and, a quote unquote configurable system, just because you're not writing code doesn't always make it, a magic recipe for a better deployment, et cetera. So it's not as simple as being, if everything were low code or everything were no code, it would be, the world would be an easier place, a happier place. It's not quite that, not quite that simple, but we are seeing a lot of, self-enablement, essentially, let's call it that, in this particular space, where the business itself, the science itself can direct what kind of orchestration and what type of data needs to be collected along with these requests, and achieve that in a simpler fashion than sort of the older style, sit down and write detailed code, sorts of approach. So here, I think a lot of folks are looking at the things in this space to really help them, like I said, manage work that is increasingly becoming more and more distributed across geographies, within companies, across organizations, so external work, contract organizations, contract manufacturing organizations, contract testing organizations, et cetera. So that's a big driver here. Like, we can have a better picture of what work is actually going on overall, and a better way to sort of orchestrate that, then that'll improve, our overall efficiency and effectiveness. And if we can use this at the same time to eliminate some of the redundant data capture problems. So if we can use the orchestration system to make the LIMS more effective, so it knows, to expect these samples this time from this, these things for these tests, et cetera, rather than having to recode things that come from accession sheets, et cetera, receipts of samples. Then that'll improve the overall process. A lot of the technology aspects of things that are happening here, we're moving, I think rightly so, within an R&D environment to more event-driven models of things. This has been an approach on the corporate enterprise side of things goes back way back. It's well known to be a more scalable approach from a data volume perspective. It helps you isolate inter-system dependencies so that in a point-to-point sort of manner, if one of the systems is down, it gives you some resilience, against those types of things. So these event-driven models, and that this area is sort of dominated by, from a technology perspective, are helpful, and sort of these are better practices these days from an engineering perspective. We've got some example vendors down. This is not a complete list by any stretch, but this is an example. These are examples of the types of vendors who are offering approaches that are relevant in this particular space. So this is one big chunk of sort of lab of the future work, introducing orchestration, looking to help use it to automate more, eliminate more, as Ken said earlier, of the digital version of the cut and paste by bringing systems to some level of having better knowledge of each other without doing the point-to-point integration at the same time. So this is a big area of trend right now.
Yeah, if I think back to like 2005, 2010 or so, where ELNs were the hot thing, this area seems to be very hot compared to that time frame back then, right? Yep. All right. Yeah. So Dave, should we move on to
the next bucket of trending?
Yep.
So
Yep.
this bucket is a very different one. This is not really about technology. There's some vendor stuff written down here, et cetera. But the principal, work that's happening around data governance, the principal challenges in data governance are not technical. They are organizational, cultural challenges. So establishing data governance programs and having them actually provide a return on investment is an organizational problem. It's a people problem, almost entirely. The technologies that can help you do these kinds of things are relatively simple and straightforward and not very expensive. The efforts that are actually involved in this area, establishing these types of things, are vastly dominated by the people part of things, establishing an organization, establishing roles in an organization, communicating and getting people on the same page with respect to why are we doing this, why is it important, what is actually needed, and right sizing those types of things as well is really the majority of the work, majority of the effort, and the kinds of things going on here today. So establishing the organizational structures, building within the organization shared understandings of common aspects of data in order to actually, in a practical way, improve data quality. So when we speak to each other about aspects of data, we're speaking the same language. We have a shared understanding of critical packages of data in our organization that we need to harmonize on, that we need to actually sort of be able to speak, to understand each other on in order to be able to collaborate. So again, this one is a separate bucket because it is almost entirely sort of a cultural, organizational, people-oriented type of things. There's bits of technology that can assist in this to establish a reference data hub where common terms and such are actually stored. But again, that's a small part of the problem here. It's actually really all about like how do you put the organization together, building the shared understanding, with each other, having, going through those exercises, et cetera. And I think on the next slide, we've got an example of this, of the types of things that go on in this particular space. And this is a very oversimplified view of the kinds of things that happen in establishing, a valid and useful data governance practice is getting to agreement on, what are the things that are important to us and how are we going to speak of them. So when we speak in an organizational sense or in a scientific sense of what a material is, it's independent of a system again. There probably will be a reference system or maybe multiple reference systems that represent, sort of the life cycle, if you will, of real materials. But we have to develop an understanding of the difference between a material and a lot and a sample and a container and all these kinds of things and what the important relationships are. This is a very simplified diagram, in the real world, like taking a client through this type of exercise, there's more process to it and other, variations and flows, et cetera, kind of come out depending on the nature of the work that's going on, particularly like, for example, contract manufacturing versus in-house types of stuff. There's, sort of fundamentally different relationships. But the principal exercise in here as part of the beginnings of the kind of data governance work that goes on in Lab of the Future and digital transformation types of exercises is to get to this kind of a picture where there's 20 things that we need to agree about, we need to agree upon, so that we can communicate with each other. And then we can establish what systems have what relationships and what work practices have relationships with those things. So that helps us drive like these overall high value, result-focused data flows is coming to these types of agreements. So when we talk about a result, we know a result is always going to be related to a sample. Now, again, that's an overly simplistic view, and in the real world, in practical senses, we do have results associated with lots, for example. Things that deal with, you do enough testing, you wind up with a COA, and that would be associated with the entirety of the batch. But again, relatively simple examples of these important concepts that we're going to agree upon. So when we say material with a capital M, this is what we mean as an organization. Independent of systems, in this. That's part of the importance of building this kind of picture.
Right, and this just gets exacerbated with M&As, and multiple systems that are doing the same thing. But this really gives you the baseline, right, of being able to start employing this type of data into these newer models, these AI and machine learning and other systems that are going to give you more benefit with your data, right?
And business practices are important here too. What is a material in a manufacturing sense is often very different from what is a material in an R&D sense, let's just take development sense. And then research might have its own notion as well. Being able to agree that there's going to be those differences, but agree upon what definition is going to be central to the data architecture, and then how to map those other definitions into that is really the exercise around establishing practical, beneficial kinds of data governance. Yeah. Can't govern what you don't understand at the end of the day. So having governance around materials is going to be really difficult if you don't have some fundamental agreements on what is a material and what is not a material. Yeah.
Right. Which is probably a good segue into some of the technologies used to manage these types of data governance items.
Yeah. So again, in an overview sense, we mentioned a lot of technical change, a lot of interesting things constantly happening, of course, from a technical shift. There's been a lot of interesting growth, in sort of some of our underlying platforms and technologies. I'm not mentioning vendors here because there's a whole slew of these things, and it's just not very helpful to go through the laundry list of things. But a lot of what I'm involved in now with clients is sort of like how to right size some of these technologies into the right places. Specifically called out on the slide here is multimodal data storage, and this is like how to mix and match essentially different storage models, relational and document models, and time series data and graph data with the use cases that actually drive those, that appropriately drive those types of things. So looking at real problems to solve, for example, in batch genealogy, like what are some of the types of representational technologies from a data perspective that we can use to more effectively solve those kinds of problems more rapidly, and then provide the ability to iterate on them as well. So, again, what I said before about one of the learnings of the last 20 years or so is about the importance of separating what the organization, the important data for the organization, the results, quote unquote, themselves from the operational systems. And that opens up questions about how do you represent that sort of, how would we want organizationally to have our results tied to our samples and have our samples tied to our batches and our batches tied to our materials? What are we going to want to do with those things from a reporting, visualization, AI, et cetera, point of view? And then how can we use some of these data management technologies to more effectively solve those kinds of problems? Separately from buying a LIMS system that lets you accession batches, accession samples and associate them with batches from an operational point of view. Here I'm speaking really about sort of the overarching data flow within the organization. So a lot of things going on in this space as well.
Yep. And last but not least.
Yeah, so then in this last bucket then is really about, okay, so if you've got, if you're sort of orchestrating these data flow problems, across all the different systems where they're relevant, and you've got a, agreed upon definition of what these important elements of data are, and you're setting up, governance around them, within the organization, and you're doing some cool things with how you're actually, facilitating the management of that stuff, then what are you going to do with it? And that's kind of this last category. So the things that people really want to do at the end of this cycle then. So obviously there's dependencies between getting into these types of things and some of the other things I've already called out. But we really want to be able, at the end of the day, it's something we've been saying for decades, right? Extract more value from data we've invested in, right? We paid money to have people run experiments, and put up money for consumables and materials and all these other things. We really want to get the maximum value out of that we possibly can. How do we improve our automation, around things? I spoke before about just sort of avoiding duplicate entry of things using orchestration technologies in order to bring systems together. In the non-R&D space, this has been a big effort in departments like HR and finance around RPA, robotic process automation, for quite a while. It's like, how can we take routine types of activities and automate them more effectively? And more flexibly to move data around, so we know, for example, when a sample gets accessioned, we have to do the following kinds of things, when something is, et cetera. So these are types of things that people want to be able to do with data. There's a lot of this, though, that is highly iterative. There's a tendency to want to jump to the end game here, which is like, gee, I want to just take all my data and throw it into some algorithm, tell me what to do next, or what this could become, from a properties kind of point of view. But to some of the things I said before, if you don't have solid control over what your data is, then you don't have comparability of data, necessarily across labs and such, and that can frustrate the ability to use that data in these ways. So strong metadata structures, which goes back to data governance again, to really help improve the quality of the data, and then using that to provide more self-service data access. So if we can give scientists the ability, one of the sort of main goals here is giving scientists the ability to find relevant experiments, relevant results data from other people in the organization, so that they can use that however they want to use it. Not necessarily for a fancy AI ML model, but just even scientifically, of course. These are the types of things that people are shooting to do.
Yeah, and I think we've seen many of our customers moving towards this modeling activity so that they can take advantage of their data and start taking advantage of some of these newer AI models, which is really, really cool to see in the industry right now. Really great stuff. And there's a lot here, right? Where do you start? How can we take baby steps towards this, or even just walking steps? What types of things can we do right now? You guys do right now at your companies to get started, and that's where we've started to put together some blueprints, right, that help enable the lab of the future, or your lab of the future rather. And where we've gone with that is, we help out organizations everywhere from strategic direction assessments, which this Lab of the Future, our Lab of the Future programs start out in, down to, your Lab of the Future might involve technology selection. So we have blueprints for that. We have blueprints for implementation projects, change management, et cetera. So really being able to provide the end-to-end process for defining, selecting, and implementing your Lab of the Future technologies, but also processes, as we mentioned before. Really, the next set of slides will start off with how we compartmentalize a strategic direction assessment for Lab of the Future, which several of our customers have embraced and are on that journey. So take a look at that. We have a stepwise approach for doing a Lab of the Future assessment, from defining vision and business drivers to confirming business and data capabilities to creating a high-level architecture, and then really a roadmap, an actionable roadmap with actual projects that you can go ahead and get started on. And this whole process, right, is not a year-and-a-half long process. This is typically, depending upon the size of the organization, it could be 10 to 14 weeks where we really dive in and work with your team to help you transition to your Lab of the Future. Some artifacts from each one of these stages, are for defining vision and business drivers. Some of those might be, we talk to your leadership, and it's like, okay, you do want to establish data governance. Dave just talked in detail about that. That's a huge part of it, right? Excuse me. You might want to simplify the number of access points for your scientists to get their workflows completed instead of going into 16 different systems to be able to do a bioreactor study. You might want to be able to, as a guiding principle, establish single sources of truth. Your IT group might have a software as a service only mentality. So that's really going to direct, all of these things will start to direct your Lab of the Future, right? As we get into confirming business and data capabilities, this is where we interview your department leaders, their direct reports, subject matter experts about not only their pain points, what opportunities they see, what gaps they might have in technology or workflow, and also understand the data flow as well as collaboration workflow. So it's really interesting to have these interviews and interactions to really get a holistic view of, it's not just one laboratory that needs a Lab of the Future. It's holistically an entire department or an entire company from R&D through QC, right? So that interview process is key. We don't workshop your teams to death at all. We really want to make sure that we're cognizant about your subject matter experts' time. They have a day job. They have to do science. They're at the hood or wherever doing what they need to do on a day-to-day basis. So we have a methodology for making sure that we're really strategic about and surgical about the use of your subject matter experts' time. When we do confirm those business and data capabilities, some of the artifacts that we'll create are our business needs heat maps, pain points heat maps, systems inventory, and understand the pain points around there. Might have a capabilities assessment around different technologies to help drive and confirm where we want to go with your high-level architecture for the future. So we talked about a lot of these different areas already today. We would need to understand and be able to double click on what pieces are good for you and your organization, because not every organization is the same. You might be a CRO, CMO, or biotech, pharma company, CPG company. You might have different needs, right? So and it's not all about a single system. It's really we see that no single vendor can really supply all the pieces to this. So it really requires, no pun intended, some orchestration around that, right? And then once we've done that, we can really define the next steps for your organization. Again, this is like a 10 to 14 week process, and we can develop that roadmap for you with actual, projects and programs that could be implemented or should be implemented in a specific order based upon the priorities and results of the previous work that we just did with your team to really get to where you need to be. So not only are these projects, technology-based perhaps, but they could also be people-based with like change management and so on involved as well. So in summary, we went through some of the trends today. We went through how we got here. We also just discussed, what Astrix can do to help you guys get to your lab of the future. But I really thank you guys for your time and attention. And we'll go ahead and move to the questions and take a look at those if we have any.
Great. Yeah, a couple things here before we transition over to the Q&A. For the folks who weren't on right in the beginning, want to obviously encourage you to ask questions. You could just type your question in on the GoToWebinar panel, and we won't read your name or we won't read your company. We'll just read the question out loud. I know we've got a few on the floor that we'll tackle in just a moment. In terms of questions, we'll handle that. Next steps wise, if the topics you heard today were interesting and you wanted to talk a little bit more about a Lab of the Future project that you may have ongoing or planning at your organization and you'd like to talk to Astrix about it, reach out to the gentleman on the screen here, Michael Zakowski. The email is right there, mzakowski@Astrix Inc. Michael will get you pointed in the right direction about how to engage with Astrix to help with this or obviously other service projects that you may have going on. Certainly you could check us out at astrixinc.com, and there's a myriad of ways to get in touch with us, either by chat or by form or otherwise on the website. The other thing I want to point out is, again, if you weren't on right at the beginning, this session has been recorded, and we're actually going to stop the recording right now.